Today I have made a 555 timer oscillator circuit, and I will test the circuit. Here we have the different charts. This one is voltage over time. This one is FFT, so we can see the frequency spikes. And currently there's a spike at 1 Hz, which is basically DC. And there is also here, this is frequency. So it tells me the frequency, but it only works with the relatively good sine waves. So for example, if I touch this, we can see that the voltage grows. We can do freeze, and here we have a sine wave at 49.98 Hz, and this is of course the frequency of mains because of parasitic capacitance between me and live wires. I should say that the negative of the scope is attached to ground right now because it's easier for me, since the ground of the power supply, the GND, the negative of the power supply, is also attached to the ground. So like this, it's easier for me. We can also see that if I detach it from ground, the voltage drops. Okay, so trying to test stuff. So you can't really see it, but there's a LED blinking. This thing, it's red LED, and in the camera it looks like it's blinking slowly for some reason, but it's actually blinking quite fast. So we can measure it. So first the capacitor. So measure it, and then you can do freeze, and we can see that this is almost a triangle wave. This is from the capacitor charging and then discharging. We can also see that there is some noise here, which is noise, I assume. I think this noise comes from the 555 not being perfect, maybe. It's supposed to be like this, I don't know. Maybe my 555 isn't working. I can also regulate the frequency. So like this, it's one of the lowest frequencies I can make. If I turn this potentiometer, the frequency rises, and I can no longer see the LED blinking. If we measure it here, we can see that the frequency is different. We can also see that the duty cycle has changed, so the capacitor now charges slower than it discharges. This is because the duty cycle is like the ratio of the two resistors. To bring the ratio back, to about 50% duty cycle, I will turn the second potentiometer. Like this, it looks better. Freeze. Okay, it's closer to 50% duty cycle. So this is the capacitor voltage. Okay, we can now measure the voltage, the waveform of the third pin of the 555, or the output. It is this. It's not 50% duty cycle. I'm not going to change the values. As you can see, it's a square wave. However, there is some noise here. There's also some noise here. Yes, it's not a really clean sine wave. I mean, in a square wave, there's this noise, which usually isn't supposed to be. But I do sort of see a pattern in this noise. So unfortunately, the frequency meter does not work, since this is a square wave and it doesn't really work with square waves. The FFT is detecting a frequency at about 0 Hz. That's DC, since here we are at 0 volts and the peak is at 10.6 volts. I expected that to be 12. Anyway, to this I have a BJT attached, an NPN transistor, and this basically acts like an amplifier. This very small transistor. You can see it's basically the same waveform, not so much changes. There is a reason why they used NPN transistors for analog circuits. Then I can measure the MOSFET. Freeze the MOSFET, and the MOSFET is inverted because it sort of acts like a NOT gate. Yes, here it is. It is also a square wave. these edges look... Of course, the edges aren't very sharp. They're a bit rounded. This is also because the gate of the MOSFET needs time to charge. But I should actually see if directly the output... Okay, so this is directly the output of the 555. We can now look if the edges are sharper. They're not particularly sharp. There's also like this bump which gets eliminated by the MOSFET. Again, probably the gate capacitance smooths it out a bit. Now we can measure the voltage at the LED. Maybe I should measure it on the other side. And it looks like the same. Okay, so here it's basically the same as the MOSFET. However, the edge should look a bit different. That's basically the same. The noise remains though, over here. The noise looks different. The FFT shows us it's basically noise. There's a bunch of different frequencies, all of them relatively low, except the spike at about 0 Hz. So yeah, I guess there isn't much more to add to the 555. It is a useful circuit. It was invented many years ago, and it is still used as an oscillator because it's easy to use. And outputs a relatively good square wave, or sort of triangular wave at the capacitor. And in future, I think that I would like to at least try to use this 555 timer to try to make a Tesla coil. Since I do have a Tesla coil with no driver, I would like to try to power it. But for now, that's it. So bye.